Have you ever wondered how a car works? It's a question that has piqued the curiosity of many. Today, we're going to delve into the fascinating world of car anatomy. Our aim is to educate you about the core components that make up your everyday vehicle. In this journey, we'll be exploring the four main parts that are fundamental to a car's operation. First, the engine, the heart of a car, converting fuel into power. Next, the transmission, which takes that power and makes your car move. Then, the brakes, the safety guardians that allow you to control your speed. And finally, the suspension that absorbs bumps and shocks, providing you with a smooth ride. Each of these components plays a vital role in the overall functioning of a car. They work in harmony, creating the symphony that is your daily drive. By the end of this video, you will have a basic understanding of how each of these components contributes to the functioning of a car. The heart of a car, the engine. But what exactly does it do? The engine, often referred to as the powerhouse of the car, is responsible for converting fuel into motion. It's a complex piece of machinery, with hundreds of moving parts working in harmony to keep your car on the move. But how does it do this? The magic happens through a process called internal combustion. Let's break it down. The internal combustion engine operates on a cycle that consists of four main stages: intake, compression, combustion, and exhaust. Each stage plays a crucial role in transforming fuel into power. The process begins with the intake stage. This is where the engine breathes in, drawing air and fuel into the combustion chamber through the intake valve. The piston then moves downward, creating a vacuum that sucks in a precise mix of air and fuel. Next comes the compression stage. Here, the piston moves back upwards, compressing the air-fuel mixture. This compression makes the mixture highly explosive, priming it for the spark that's about to come. The third stage is combustion, also known as the power stage. The spark plug fires, igniting the compressed air-fuel mixture. The resulting explosion pushes the piston downward, generating power that turns the engine's crankshaft. This is the force that ultimately drives the wheels. Finally, we reach the exhaust stage. The piston moves back up, pushing out the burnt gases through the exhaust valve. This clears the combustion chamber, preparing it for the next cycle to begin. This four-stage process occurs hundreds of times per minute, with each cylinder in the engine going through its own cycle. It's a symphony of precision and power, all happening right under your car's hood. The engine, in essence, is a remarkable piece of engineering. It takes something as simple as fuel and transforms it into the power that propels your car forward. It's the heart that keeps the car alive, pumping power through its mechanical veins. So, in essence, the engine converts fuel into power, making the car move. Now that we understand the engine, let's move on to the transmission. The transmission is an ingenious part of your vehicle that plays a crucial role in its operation. In essence, it's the bridge between your car's engine and its wheels. The transmission takes the power generated by the engine and delivers it to the wheels, allowing your car to move. So, think of it as the middleman in the car anatomy that makes it possible for you to drive from point A to point B. The transmission works by using gears and a clutch to convert the engine's power into torque, which is then transmitted to the wheels. The process begins when the engine's crankshaft rotates. This rotation is transferred to the transmission, where it's adjusted by the gears to match the car's speed and load conditions. The output is then sent to the wheels, which move your car forward or backward, depending on the gear selected. Now let's delve a bit into the two main types of transmissions: automatic and manual. Automatic transmissions are designed to do all the work for you. Once you select the drive mode, the transmission automatically changes gears based on your speed, using a complex system of sensors and hydraulic pressure. This makes for a smoother, more effortless driving experience. On the other hand, manual transmissions, often referred to as stick shifts, require the driver to manually change gears using a clutch pedal and a gear stick. This gives drivers more control over the car's performance but can be more challenging to master. So whether you're cruising down the highway or navigating city traffic, it's the transmission that's doing the heavy lifting, ensuring the engine's power is efficiently transferred to the wheels. This intricate system of gears and clutches is what keeps your car moving, making it an integral part of your vehicle's anatomy. In simple terms, the transmission controls the power generated by the engine to the wheels. We can move, but how do we stop? That's where the brakes come in. Brakes are a fundamental component of any automobile, designed to halt its motion by absorbing the vehicle's kinetic energy. But how does this process work? Let's dive right in. When you press down on the brake pedal, your car's brake system springs into action. This pedal is more than just a piece of metal. It's the starting point of a complex chain reaction that enables your car to stop safely. As you apply pressure to the brake pedal, it activates the master cylinder. Now, the master cylinder is a vital part of the brake system. It's a sort of pressure converter. When you press the brake pedal, the master cylinder uses mechanical force to generate hydraulic pressure. This is because your foot's force alone wouldn't be enough to stop a speeding vehicle. This hydraulic pressure is then distributed through the brake lines. These lines are like the highways of the brake system, carrying the pressure to the brake pads at each wheel. The brake pads are the heroes of our story. They're designed to handle extreme conditions and high temperatures. When the hydraulic pressure reaches them, they clamp down on the brake rotors, which are attached directly to the wheel. This creates a large amount of friction. But here's the clever part. This isn't just any friction, it's purposeful, controlled friction. The brake pads are made of materials specifically chosen to handle this sort of heat and pressure without wearing down too quickly. This friction between the brake pads and the rotors generates heat, a lot of it. And this is where the magic happens. The heat produced is essentially the car's kinetic energy being converted into thermal energy. It's this energy conversion that causes the car to slow down and eventually stop. But of course, the brake system isn't just about stopping, it's also about control. The system is designed to allow you to modulate your speed, to slow down just a little or to come to a full stop, all while keeping the car stable and under control. In essence, the brakes convert the kinetic energy of the car into heat energy, bringing the car to a stop. Now let's discuss the suspension, the system responsible for a smooth ride. Imagine you're driving on a bumpy road. Those jolts you feel? That's your car's suspension system at work, absorbing the shock to ensure a smoother ride. The suspension system is the unsung hero of your car's anatomy, tirelessly keeping you comfortable and your car stable, no matter what the road throws at you. So what exactly is this system made of? It's primarily composed of three parts: springs, shock absorbers, and struts. Let's start with the springs. These are the resilient workhorses of your suspension system. They compress and expand to absorb the energy from bumps and dips in the road. The type of spring used can vary from coil springs, commonly found in most cars, to leaf springs, often found in larger vehicles like trucks and SUVs. Next up, shock absorbers. Despite what their name might suggest, shock absorbers aren't there to absorb the shock. That's the spring's job. Instead, shock absorbers dissipate the energy absorbed by the springs, preventing your car from bouncing around after hitting a bump. They do this by forcing hydraulic fluid through tiny holes, which slows down the movement of the springs. Lastly, we have the struts. These are a structural part of the suspension system, providing a place for the coil springs to sit. Struts also play a role in steering, as they pivot when you turn the steering wheel. Together, these components work in harmony. They maintain constant contact between your tires and the road surface, giving you better control and handling. They also protect the rest of your car from damage due to road shocks, ensuring you and your passengers have a safe and comfortable journey. So, the next time you're driving down a pothole-ridden road, spare a thought for your suspension system. It's working hard to keep you comfortable, your car stable, and your ride smooth. In summary, the suspension system ensures a comfortable ride and keeps the car stable and balanced. So there we have it, the basic anatomy of a car. We've journeyed together through the heart, brain, and muscles of these incredible machines we call cars. We delved into the engine, that heart-pumping power to every corner of the vehicle. We explored the transmission, the brain if you will, making critical decisions about power distribution. Our journey took us to the brakes, those essential muscles that bring us to a safe halt. Finally, we examined the suspension, the car's very own shock absorbers, ensuring a smooth ride regardless of the terrain. Each component we've discussed is a crucial gear in the intricate clockwork that makes a car function. They work in harmony, each playing its part to ensure that your journey is safe, comfortable, and efficient. Next time you hop into a car, you'll know a little more about how it works. Keep exploring, keep learning,